Hello, I'm Richard Schneeman. Today we'll be doing some live debugging of a Sprockets issue. This Sprockets bug existed for over a year, but this is the first time I've been able to reproduce it. This is an open source app I run called Code Triage. It helps you contribute to open source. Here's a commit after the bug shows up. I'm going to start off by copying a script that shows the issue. First, we clone the app. Then we set up the database and check out a specific commit. Next up, we remove the assets if they exist and call precompile in production mode. Once it's done, we'll copy this repo into a different directory and then delete the original directory. Moving directories is needed to reproduce the bug. Next up, we check out the failing commit and run precompile again. Okay, so it fails. Sprocket says it couldn't find the file, even though that file definitely exists. Notice that the path where it's looking for the file is wrong. It says temp repro code triage, but we are in the temp repro code triage -after folder. That's the bug. It's what we're going to try to find and fix. I've not previously fixed this bug while I've edited the video to remove some ums and ahs. It's otherwise totally live experience. You'll get to watch me mess up and learn. So let's get started. Okay, first up, we're going to use bundle open sprockets to open up the source code. Open up sprockets in my editor, which happens to be Sublime Text 3. And then we want to go back and take a look at the backtrace. So and start from where it ended. Okay, so it couldn't find the file. That makes sense. So this was called from 59. Okay, so it came from somewhere inside of the cache. This was called from fetch asset from dependency cache at 318. Okay, this gets a little bit convoluted. This is called from line 43. Okay, so how Sprockets works is load is one of the main top level APIs. You pass in a URI, so I can do a little puts debugging. Recall this and show you what's going on. So what's happening is, first of all, we are going to try and require this config manifest.js. I can show you what that looks like. If you're not familiar, if you've not been using this version of Sprockets, we have a manifest file, and it basically says these are all the things that we want to build. So here's application.js, and as soon as we link that, it's going to try and find it, load it, resolve it, and then actually produce that as a artifact. So that's what we see here. And just the way that Sprockets is written, there's this kind of whole pipeline thing that we don't need to necessarily hopefully get into. So you can see here it's called with pipeline self. And then it actually starts to process that. So application.js tries to be loaded, and before we try to load anything else, that's when we hit this error, we hit this exception. So what we're saying is this is the time when we are running into the bug. Okay. So the unloaded asset class is kind of just a helper class that lets us do things like pull out params easily. These things, the type application equals JavaScript. And if it happened to have a key in it, then an ID key in it, then we basically are saying, hey, I know the exact cache key of the item that I'm looking for. Go ahead and pull it from cache. That's not the case because we don't have an ID key here. No ID key, no ID param. So we're going to hit this. So you've already kind of seen this is how this was showing up in our backtrace. So fetch asset from dependency cache is a method, and it takes a block. And let me see. So we ran into the error actually came from inside of there, which came from line 61. Did I? Yeah. Okay. line 61. Really? Oh, yeah. Let's okay. There we go. Line 59. So it came from this load from unloaded. So let's take a look at this. So fetch asset from dependency cache. So we try to get a dependency history key. And that looks a little bit like this. It's going to have state all of the different dependencies of that file. Asset URI cache dependencies depends on the manifest. Pipeline self, and then I'm not sure what the rest of this is. It's important, I'm sure. And basically what is happening is when you generate an asset, you don't only cache the output asset, you also cache each of the fragments of the assets that are used to build that asset. And so what I think is going on here, I have all this documentation, I could maybe read it. It tries to retrieve the last number of histories of an asset of the cache. A history is an array of unresolved dependencies. Yes. Okay, so that's what I was getting into. I love it when I've written documentation for myself. Okay. So the history would come out from there, and essentially we still probably want to do this just for clarity's sake. Okay, there we go. So we're going to try to load from history. So you can see, wow, with that previous file, there's a lot. With this manifest file, there's a lot of history. And this is all of the different things that were involved in it. These are basically all of the different dependencies that were needed to create to compile that file. Okay. So if we go back down here, if we end up so we want to expand all the dependencies. I mentioned that we cache. We want to cache things in a relative path, though when we use them, we want to use them in an absolute path. So if it starts with this thing, then we're going to expand it from the root. Otherwise, we're going to just use the regular path. And then we are going to yield those dependencies. So this calls the previous block. All right, so we come back up here. So each of those dependencies will get passed into this. So as a paths. So you can see what that looks like here. Get rid of this. Okay. All right, so for this file, for the manifest.js, it's going to be a big, long, honking bunch of file digests. And what we want to do is resolve dependencies. So resolve dependencies will map over each one of these and resolve it. Kind of makes sense. And then we digest the result of that. So at this point in time, we figured out, okay, we know where manifest.js is, we know where assets, images, shneems, SVG is, and we generate a digest. From there, we can pass that digest into our little helper class, remember our unloaded helper class, and generate a digest key, and then look in the cache and see basically if nothing has changed, if all of these assets are unchanged from the last time we compiled, then the digest will stay unchanged, and we will be able to pull it from the cache. So this will return a URI, and then from there we can then pull the top level asset from the cache. I know this sounds all really convoluted, but it's kind of necessary due to just all of the different things that Sprockets does. Now you can see that for the manifest file, we produce a pretty hefty sized array, but for application JSERB, nothing. So that's why we call this load from unloaded, which you can see right here. I guess 61, line 61, boom, and which calls load from unloaded. 104, and it's going to check to see if that's a file, if that file exists. And in this case, oh, you know what? We've already got our bug right here. So at this point in time, before we even call load, we've got the bug. So let me see. repro/code triage. All right. So somewhere in between our first, between here and this, we are generating this as a file. So one little trick I like to do is have Ruby tell me where that came from. Use object space. So we can use this little helper method. And this helper method will tell us where the object came from, where that string came from. All right, so this helps a little bit. It tells us that it came from core extension Marshall, line 4. I could open active support and take a look there, but I kind of don't need to. It's also interesting. We can see where else these strings were generated. Wow, that's a really long one. You can see this one was generated at URI utils. Unfortunately, it's not very helpful because the answer is Marshall. So this came from a cache. This came from unmarshall. I'm going to go ahead and open it actually and see what is there. Bundle report. Marshall. It was line 4, maybe? Line 4. Line 4. Ooh. Okay. Load. Let's see. Let's see. Here we go. Oh, I do that all the time. I hate it. When I'm meant to press up twice and I press up once. There we go. You can also use Command R, which I've used previously. Okay, so this tells us some interesting things. Loading. This doesn't really tell us anything. Oh. So here's our IDs. So that's what was loaded. Maybe that does tell us something. You remember before that we used the ID to generate a cache key. So what I'm going to do is look on disk and see if I can actually find that cache entry that corresponds to this ID key. Okay, how do we do this? It's manifest pipeline ID. Okay, so let's follow this. If the ID key... see. 5 is not in here at all? Where are you? Okay, so we load this first, and then we load this. So I think I need to. I wasn't able to find the file on disk because I'm using the ID as opposed to the cache key generated from the ID. What I'm going to do is see if I can grep for the files to see which files contain that ID key. I found some results, so now I will save them in Evernote so I can look at them later if I need. Where were we? All right, so this is what is inside of a cache file. You're not supposed to look at them in a text way, but it's basically a kind of a semi-binary file. It's a Marshall format. Let me see. Here we are, repro/code triage. Okay, good. So this is a good little breadcrumb. So this is definitely a bug. We have our we should not have a full path inside of the cache anywhere. So yeah, you can see this is what the relative path looks like. This is the absolute path. It's got those three jobbers right there. Okay. Can I cache? Okay, let's see. I'm going to try to pull the cache from the ID key using Sprockets code. Okay, so wrong method. Have to instantiate a new object and then call the cache method on it. And great, I've got the cache object, and I'm going to try using the ID key. Unfortunately, that's not going to work because the ID key gets turned into a cache key. We don't use the ID key directly. Instead, we call this asset key method, and let's see where that came from. I added a debugging statement to see what gets put into the cache, so we can hopefully see when our bad values get stored and how they're stored. Sorry, get rid of that jazz. Okay, so these are all, what key are these in? So it's more than just that one. File, 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 to load. Oh no. Okay. So what's happening is we've got this hash key to load, and I actually thought this was impossible, which is why debugging exists. But it has stored a set of file URLs, URIs. This is how Sprockets likes to store things. And they're all absolute paths. So first of all, that's bad. So now I need to figure out how they got there. Okay, let's take a look. So to understand what toLoad does, I'm going to store this. These are my breadcrumbs. So what toLoad does is it's a way of saying, so first of all, manifest.js. These things are called directives, and it's a feature of Sprockets. You can link, you can require, you can do a couple of different things. Require is basically the same as saying like, hey, take the contents of application.js and put them in this file. So if we actually open up JS, here B, you can see it's just nothing but a bunch of require. And when you actually generate the file, it'll start with jQuery and then jQuery UGS and then local time and Bootstrap and have all of those contents. So another thing that you can do with a directive is to load a file. And so you can see right here, required goes right there, but toLoad is something that I added relatively recently. So you can see all it does whenever we want to load something, all it does is appends it to this array. So depend on asset. Let me see, what else is there? toLoad, process, link. Okay, so link is exactly what we just saw. If you remember here, link. So link says we eventually want to load this asset. We want to generate this as an end artifact. Okay, so the issue prior to this patch, the reason this patch exists is there was a circular issue with some of these where you would previously we saw depend on. Yeah, here. So you can have one asset depend on another. And what would happen is you might be in a top level asset, foo.js, which depends on bar.js. Bar.js depends on baz.js. And then baz depends on foo, which is the first one. So in order to fully load the dependency tree, if you actually tried to load it right then, right at load time, at this time, then it ends up causing a circular dependency and you just can't do it. So instead, what my solution was to stash these all later to be loaded. And then what we end up doing is, so those all get added in the directive processor. And the only other place that we reference this is in the bundle processor. And so the bundle processor and the directive processor kind of go hand in hand. And it takes each one of those. And at this point in time, the top level asset is already fully resolved. So at this point in time, foo.js is an asset as far as Sprockets is concerned that can be referenced from other assets. So if Baz says, hey, I depend on foo.js, Sprockets will be like, great, we've already got it. We've already got it in memory. We don't need to do anything else with it. And so at this point in time, it's safe to loop through each one of these, load them, and then we add some data into the original asset. But these should be called hand in hand. So we add things in the directive processor, we take them out in the bundle processor. That just makes sense. So let's do this. Time for some more debugging. Let's get rid of whatever we had before. Okay, so loader, get rid of most of this. Okay, I still think I want URI. That's kind of our top level thing. Okay. And oh yeah, it's the key here is that I'm actually deleting the key. So I didn't think it got into the cache, but apparently it does. Oops. There we go. It's a little better when you can spell things correctly. Okay, so we try to load the manifest.js, which promptly tries to load the pipeline self, which calls the bundle processor, but does not call the directive processor, which is odd. Maybe we do need to look at the pipelines. Sprockets.rb. Here's the pipeline.
I'm not actually sure which processors are in this pipeline, so I'm going to need to inspect that somehow. Here I'll just record the output of the processors and then return that.
Okay, so these run backwards. I think.
I'm looking for where the bundle processor gets called, and I'm not seeing it.
Weird. You can see the directive processor being called. Yeah, sprockets. Ugh.
Where do processors get called?
Okay, so this all happens in load in unloaded right here, processors. So we should see that. Processors dot inspect and see what they are. Yeah, that's why. I was doing this backwards. So there is no pipeline here. That's so it calls the default pipeline. So I was inspecting the wrong output. So how Sprockets works is assets don't just go in. There's kind of this quote unquote pipeline. You can think of it as a way of flagging a file. So for instance, there's a debug pipeline, and what that will do is it adds a source map comment onto the bottom of the file. And the reason it needs to be a pipeline is in order to generate that you have to actually already have the asset to begin with. Yeah, that's why this source map has nothing. There's no processors. It's just the source of the file. Self, I can never remember what the purpose of self is. I think self is used in the bundle processor, maybe the directed processor. Not exactly sure. But the default ones are, for this file anyway, are bundle and uglifier. And so bundle gets run first, I think. Yeah, I'm pretty sure it runs backwards. So bundle gets run. Okay. So bundle gets run. Gonna just clear that up. And then this is actually where the other load comes from. Let's clear this up. Does this show up in the backtrace? 32? No, it doesn't. So puts URI. But I bet that will. Yep, right here. Repro code triage. Oh, wow. Yeah, the backtrace in Sprockets tends to get mangled a little bit. Not sure why that mangled it this time. Oh, it's right here. Yeah. 31. Right here. Okay, well. 32. Yep, right there. Okay. So this still begs the question of how did it get there in the first place? To answer this, can we just delete the metadata? Will that work? No. Okay. Well,
I want to see where in the loading code are we calling the cache?
I thought that we got rid of them. Yeah, so one option to just fix this off the bat would be to, in here, as you're storing it, I know this is gnarly, but as you're storing it, compress each of these so that they are, so that you're never going to have the absolute path in the cache. I'm using not empty here just as a slightly faster version of any. Let's see. No. Boop, boop. Okay. That should do it. Okay. I'm gonna move this up here. Makes a little bit more logical sense. What was the other one? Other one was to link. And I bet that makes the problem go away. Oh, well, so there.
It's not good enough just to compress two relative paths before we put it into the cache. We also have to expand to absolute paths when we take it out of the cache.
Asset from cache. To load, to link. And then make that pretty. To load, to link. I guarantee you this is going to work. Except I need to start over. So let's run the whole script again. Got all my debug statements in there. Gross. Okay. It worked.